In today's lesson, we are going to talk about pressure. Pressure is defined as force acting on a given area. So pressure is force per unit area, not volume. Where F is force and area, A is area. Pressure, it has the SI unit, standard SI unit of pascals. Deriving the SI unit for pressure following its formula, it can be pressure is equal to force, which is Newton. Force is measured in newtons, over area, which is measured in meter squared. This is how pressure is measured. In hospital, when someone is trying to measure the pressure or the blood pressure, pressure is measured in millimeter mercury. This is for blood pressure. But in physics, pressure is measured in Pascal. This is the standard SI unit for pressure. So just know this formula, keep it into your mind, and then we are going to see how we can use it. Okay. We can find also pressure in a liquid. Pressure in a liquid. Pressure in a liquid, it is dependent on the depth of that liquid. And it is given by pressure is equal to density times gravity times height. Where do you think this formula comes from? It comes from the general formula, pressure is equal to force over area. Where force, it is given by force, it is given by mass times gravity. Then the formula for area is equal to length squared. Length squared. Then, where there is mass, where there is force, we put mass, gravity over length 2. Then where there is mass, we simplify it further from this formula, density is equal to mass over volume. Where mass, making mass the subject, the formula becomes mass is equal to density times volume. Mass is equal to density times volume. Volume is L cubed. So this is mass. This means that where there is mass in this formula, we are going to replace by this, which is L squared. So now, let's go back to the formula here, pressure. So pressure is equal to force. So where there is force, you are going to put this O formula. Okay? So force, sorry, this is, yes, the same one, this one, which is mg. So pressure is equal to m gravity over L squared. Then where there is mass, you are going to put this. Then it will be pressure is equal to density times length times gravity over this, which is the formula for area, which is L squared. Then this into this will remain with 1L. So P, which is pressure, is equal to density, okay, times L, which is length, times gravity. So pressure is equal to density times, since it's pressure in fluid, this means that fluid should have depth. That depth, it's in height, so length should be in height times gravity. So I just wanted you to show you where this formula comes from. It comes from the general formula of pressure, which is force over area. So now pressure is equal to density times gravity times height. So this is the second formula of density. This means that, let's say we have fluid in here. This is a beaker, and the name of fluid is water here. So what pressure is this fluid exerting at this point? Assume this point is as the height of 10 centimeter. Then if it is at this point, we can assume this point to be 8 centimeter. Okay, from this point to this point, let me just say 8 centimeter. Then to here it's 10 centimeter. Now at this point here, it can be, let's say, if it is 12 centimeter. How would you calculate the density? So the pressure is equal to density times gravity times height. So gravity, it is a constant value. You use 9.8. Then the height, you need to use, if it is at point, let's say this is point X, this is point Z, this is point Y. So if it is at point X, this means that you need to use which value? It's 8 here. If it is at point Y, you need to use 12. If it is at point Z, you need to use 10. Now, where do you think density value come from? Well, since we have water in a beaker, this means that water, it has a constant density depending on the temperature of that water, For example, let's just say water, the standard value that you can use is 1000 density, kg per meter cubed, times gravitational force. What is the gravitational force? It's 9.8 times the height. Remember, whenever you're calculating physics, just make sure that the units, it's in meters for length. Then for mass, the unit should be in kg, in kilograms. So the height, since let's say we want to calculate the density, the pressure of water at this point, This means that we are going to use 12 centimeters. Then how can you convert 12 centimeters into meters? It's 12 divided by 100. We get 120 pascals. So this is the value for pressure. So now, how would you calculate pressure in an hydraulic system? An hydraulic, it looks like this. It has got a cylinder and 2 pistons. One cylinder is bigger than the other. It exerts different forces, but same pressure is exerted throughout the fluid. So this is how hydraulic press looks like. It has got, this is a cylinder, it has got 2 pistons. This is piston 1, okay, this is piston 2, the smaller one and the bigger one, okay. And if the force, this force is acting downward, this means that there must be a force acting in an opposite direction. If this is upward, this means this force should be downward. This is the fluid, okay. When the piston is pushed down here, the pressure that is created in this fluid is equal throughout, only the force differs. So now, how can you calculate despite having the same pressure? This means that, let's say if this is force 1, then this is force 2. This can mean that we can say force 1, pressure 1 is equal to pressure 2. The pressure that can be created here can be the same throughout the fluid, but the force for force 1 is not equal to the force 2. Since I said that the cylinder, there is a smaller one and the bigger one, this means that the smaller one, it has a smaller surface area. Then the bigger one, it has a bigger surface area. Okay, so pressure 1 is equal to pressure 2. What is the formula for pressure? Pressure is equal to force over area. So this means force 1, area 1. So this is the force for pressure 1 and area 1. This is area 2 is equal to this pressure, which is force 2 over area 2. Let's just consider an example of 10 Newton exerting on this piston, which is the smaller piston, and this is the bigger piston. And this piston, it has got a circular base with the diameter, the radius of 2, and this piston, it has got the radius of 4. Now, what is F2? How can we calculate F2, which is force 2, the force which is exerted to the bigger piston? Okay, so just like I said, the pressure that is created in this fluid is the same throughout. This means that pressure 1 is equal to pressure 2. The formula for pressure is force over area. Force over area. So this side is for piston 1 with force 1, area 1, force 2, area 2 here. Okay? So now, what is the values that we need to put here? We have the force 1 is 10. Then the area. Since this is a circular base, we are going to use the formula of area for the circle, which is pi r squared. Okay, is equal to force 2, it's the one that we are looking for. Then what is the area for the bigger piston? It's also a circular object. It's pi r squared. Okay, so now what is the value of the radius for piston, smaller piston? It's 2. So it's going to be 2 squared equals F2 pi. What is the radius for the bigger piston? It's 4 squared. We want to find F, which is the force exerted by this bigger piston. So it will be 10 over 2 power 2, it's 4 pi, equivalent to F2 over power 16 pi. Then you're going to do the cross multiply here. So the answer here will come on top. So it will be 160 pi equals 4 pi F2. 4 pi. Okay, so these two will divide, will remain with 2 F2, then this and this. Okay, this into this is 4 Newton. So 4 Newton, it is the one that is being exerted. 40 Newton. 40 Newton. So we have the dam here. This is a dam. And it is this wide, 500 meters. And its height is 80 meters. Or depth is 80 meters. So now, how can we calculate the pressure of this dam? The pressure exerted on this dam. So what data are we given? We have got the height to be equivalent to 80 meter. Okay, then we have the length, which is the width, the length of the dam, how wide it is. It's 500 meters. Okay, so now we want to find pressure. Okay, pressure on the dam due to water. So we know that since this is pressure in fluid, we are going to use the constant density for water, which is 1000 kg per meter cubed. So which formula are we going to use? We are going to use the formula which is associated with the density. Okay, so pressure is equal to density times gravity times height. I'm sure you are able to remember where this formula came from. Okay? So now, what is pressure here? What is density of the water? Where this, it represents density. This is gravitational force, and this is the height. So density is 1000 times gravitational force is 9.8. This is a constant value, and also this is the constant value. Then what is the height? What is the height? The height is 80.0 meter. So pressure, when we punch this on a calculator, what value can we get? Okay, let's try to punch on a calculator. Okay, the value that I found is 78.4000 Pascal. So this is the value. Now, this is a dam, 500 wide, 80 meters high. We have calculated the pressure. Okay, so now, how can we calculate force which is exerted by this water? Let's calculate force now. So now, to calculate force, what formula are we going to use? We're going to use the force which has pressure with force in it. So this is the general formula that we're going to use. So pressure is equal to force over area here. Now, do we have the area? We can find area. Let's find area. So this base of a dam, this is the base, and this is the height. So it's the base times the height to find the area. So pressure is equal to force over base times the height. Okay, 500 times 80. So we are going to make now F the subject, the formula. So now here, force is equal to pressure times breadth times the height. So force is equal to, what is the pressure that we found? Okay, so pressure we found to be 78400. What is the breadth? The length, it's 500 times the height, which is here, which is 8. So what is the value? So I've found the value to be 313600000. Okay, so this is the force, which is just equivalent to 3.13 by 10 9, writing it into scientific notation. This is the newtons. So this is how we calculate pressure due to fluid. We consider the type of fluid and what is its density. So due to fluid, we use pressure is equal to density, gravity, height. Then pressure is given also by force over area. This is the standard. From this, that's where this formula comes from. And I showed you how you can do it. Let's consider another example here. So let's say we have a cylinder here. This is a cylinder. with a circular base. Okay, then this base, it has got a diameter of 1.2 meters, and the height of a cylinder is 2.5 meters. And inside the cylinder there is air or gas. There is gas inside here. This is a cylinder. There is gas. Now this gas, has the pressure of 735 Pascal. So this is the pressure the gas is exerting, and this is the height of the cylinder, and this is the diameter. Now, how can we calculate the density of this gas? Okay, so the density of this gas, the way we can calculate it, it's by using the formula. What formula can we use to calculate? We are going to use the formula of pressure which has density in it, which is pressure is equal to density, gravity, height here. Now we want to find density. This means that we are going to make density the subject of the formula. So we are going to make density the subject of the formula. So density is equivalent to this is density, pressure over gravity times height. So from what is pressure? Pressure, it's 735 over gravity is a constant, 9.8 times the height. What is the height? Is 2.5. So what is the value for density of the gas? The value for the density of the gas, it's 30.0. This is how it's being calculated. The next question, to calculate the force exerted by the gas. So how can we calculate the force exerted by the gas? This means that we are going to use the formula for the pressure which is associated with force, which is pressure is equal to force over area. What is the value of force? We are going to make force the subject of the formula, which is force is equal to pressure times area here. Now, do we have the area? We don't have, but we have the diameter here. So what are we going to do with the diameter? What are we going to do with the diameter? We are going to divide it by 2 to find the radius. So force is equal to, what is pressure? The pressure that we have, it's the one which is being given here, 735 pascals. So 735 times pi r squared. This is the cylinder, the circular base, which is the circle. The area of the circle is pi r squared. Okay, so now we are going to, force is equal to 735 times what is the diameter? 1.2. So 1.2 is the diameter. So to find the radius, it's divided by 2, then squared. Okay. So force is given by what is the value? It's 831.3 Newton. This is the force.